You with that do-do-do-do. Oh yeah, oh yeah. Hit you with that do-do-do-do. Oh yeah, oh yeah. Hit you with that lotion. Oh yeah, oh yeah. Hit you with that do-do-do. Oh yeah, oh yeah.
Hi guys, today I'm going to do a review of magnetism with you. The region surrounding a magnet in which the force of the magnet can be experienced is called its magnetic field. Objects that are attracted to this quality are called magnetic objects. These objects are commonly made up of either nickel, cobalt, or iron, and those that are not are called non-magnetic objects. Magnets are dipoles, which means that they have two poles, the north pole of the magnet and the south pole of the magnet. Just like charges, like poles repel from each other, and unlike poles attract to each other. Magnetic field can be represented by magnetic field lines. These lines form a closed loop with no starting or end point. The magnitude of the field line is perpendicular to the magnetic force on a moving charge, and the magnetic force gets weaker when the field lines are far from each other. In determining the magnitude of the force, we have two formulas. For vector, the magnetic force is equal to the current times the length times cross product of magnetic field. And for scalar, we have the magnetic force is equal to current times the length times the magnetic field sine theta, in which the theta is the angle between the current and the magnetic field. The maximum is theta equals 90 degree and the minimum is theta equals 0. And for a single charge, for vector we have F equals QV times the cross product of B. And for scalar we have F equals QV times B sine theta. Magnetic field can be understood by just simply using your right hand. First, right hand rule. An electric current produces a magnetic field. Second, right hand rule. The direction of the force from a magnetic field on a current running through a wire will be perpendicular to the both magnetic field and the current. Third, right hand rule. The direction of your thumb is opposite with the direction of the force. The faster the charge moves, the stronger the force. The greater amount of charge, the stronger the force. The Earth behaves like a magnet. That's because Earth's core is believed to be a mix of iron and nickel, giving the Earth its own magnetic field. The South Pole is the North Pole of the Earth geographically, and the North Pole is the South Pole of the Earth geographically. If you chop a bar of magnet in half, you don't end up with one north magnet and one south magnet. Rather, you end up with two magnets, each having their own North Pole and South Pole.
Thank you and see you in the next video.
Gar, bagsak na tayo.
Wala akong masagot. Sa physics, ang dali, to study, sa physics. Sa physics, ang dali, to study, sa physics. Free learning, ang dali, so easy, sa physics. Sa physics, free learning at so easy. Basta learning sa physics.
Welcome back, everyone. Have you ever wondered what are the differences and similarities between electric field and magnetic field? What about the Biot-Savart law and Ampere's law? Here in Magnetism 2, we will talk about all these things. Electric field and magnetic field varies in the direction and its charge. The direction of the electric field is along the line from the source to the field while its charge is at rest, while in magnetic field, its direction is perpendicular to the plane containing the line from source to field point and the particle's velocity while its charge is moving. Both of the magnitude of the electric field and magnetic field is proportional to the charge magnitude, which is Q, and to 1 over r squared, which means it is inversely proportional to the square of the distance. Combining all the observations of the behavior of the magnetic field, we obtain an expression for the magnitude of the magnetic field at point, which is stated in Biot-Savart law. According to the Biot-Savart law, the formula for the point charges are B vector is equals to mu naught over 4 pi times QV vector cross multiply to r hat over r squared. This is for the vector, while for the scalar is B is equals to mu naught over 4 pi times QV sine theta over r squared. Stated also in Biot-Savart law the formula for the line of charge. For the vector, dB vector is equals to mu naught over 4 pi times 2 IDL cross multiply to r hat over r squared. While for the scalar, dB is equals to mu naught over 4 pi multiplied to NQ VA DL sine theta over r squared, where the value for mu naught over 4 pi is 1 times 10 to the power of negative 7 and s squared over c squared. There are two things that you need to take note. The first one is magnetic field varies with the distance. Generally, B vector is equals to mu naught over 4 pi times the integral of IDL cross multiply to r hat over r squared. The second one is the force between parallel conductors implies that if the currents have the same direction, force present is attractive, and if the current have opposite direction, the force present is repulsive. Now, let's go to Ampere's law. What is Ampere's law? According to André Marie Ampere, it determines the shape of a magnetic field in a current-carrying conductor. According to him, for any closed-loop path, the sum of the length element times the magnetic field in the direction of the length is equal to the permeability times the electric current enclosed in the loop. Now, let's do some example. A point charge of magnitude Q is equals to 4.5 nanocoulomb is moving with speed of 3.6 times 10 to the power of 7 meter per second parallel to the x-axis along the line where y is equals to 3 meters. Find the magnetic field produced by this charge at the origin when the charge is at the point where x is equals to negative 4 meters and y is equals to 3 meters as shown in the figure below. Let's list first all the given. After that, let's identify on what formulas are we going to use. In this problem, we're going to use the formula for the point charge in vector. As you can see, we don't have the value for our r and the r hat yet. So in order to get the r, we are going to use the Pythagorean theorem, which is c squared is equals to a squared plus b squared, where c is our r, a is 3, and b is equals to 4. So we get the value of r, which is 5. Use this value to get the r hat. R hat is equals to r vector over r. Our r vector is equals to negative 4m, and the direction is negative I hat, plus 3m, and the direction is positive j hat. Divide this to our r, which is 5, then we got our r hat, which is equals to negative 0.8, negative I hat plus 0.6, positive j hat. Now let's continue to find the b vector using the formula for point charge. Just substitute all the value, then let's first multiply those who have directions, the velocity and the r hat. 3.6 times 10 to the power of 7 positive I hat multiplied to negative 0.8 negative I hat is equals to 0, because according to the third hand rule, those who are multiplied with the same direction will become 0. Let's proceed. 3.6 times 10 to the power of 7 positive I hat multiplied to 0.6 positive j hat. Let's multiply first the directions. Positive I hat times positive j hat is equals to positive k hat. Now, 3.6 times 10 to the power of 7 multiplied to 0.6 is equals to 2.16 times 10 to the power of 7. So the answer for this is 2.16 times 10 to the power of 7 positive k hat. Multiply all the values in the numerator, divide it by 25, then the b vector is equals to 3.88 times 10 to the power of negative 10. The unit is Tesla and the direction is positive k hat. And that's all for the Magnetism 2. Thank you all for listening.
Hindi po.
Hindi po.
Never.
Hindi po.
Hindi mo naman siya kailangan subukan para malaman mo masama ba siya talaga.
Ang dami nang nasirang buhay dahil doon. Para sa akin, wala talagang magandang maidudulot yun.
When I was young, I was taught cheating was bad.
Marami pa akong pangarap sa buhay na gusto kong abutin lahat.
Pag ginagawa mo yun, hindi lang ang sarili mo ang iyong sinasaktan, pati ang pamilya niyo.
It's easy to say no pag alam mong masama.
Protektahan nila ang sarili nila. Sila mismo ang lumayo sa tukso ng pangungopia.
Wag.
Good day, everyone. We were going to talk about induction. Generally, magnetism taught us that a magnetic force exerted on a moving charge in an external magnetic field.
B. A moving charge produces a magnetic field. And C. A torque will act on a current carrying closed conducting loop in the presence of an external magnetic field. Electromagnetic induction is a phenomenon where there will be an induced current in the loop when the conducting loop is placed in an external magnetic field and rotate the loop by exerting a torque on it from some external source. Simply by varying the magnetic field with time, an electric field could be generated. Michael Faraday discovered electromagnetic induction, and his observations were: number 1, no current is registered when the bar magnet is stationary with respect to the loop. Number 2, a current is induced in the loop when a relative motion exists between the bar magnet and the loop. And number 3, the coil behaves as if it were connected to an EMF source. The formula of magnetic flux with respect to Michael Faraday's observation is B, or the magnetic field, times A, or the area, times cosine theta, which is then represented by 1 Weber, which is equivalent to 1 Tesla times meter squared. Mathematically, Faraday's law of induction may be stated as follows: the induced EMF in a coil is proportional to the negative of the rate of charge of magnetic flux, which has the formula E, or the induced EMF, is equals to the negative N, or the number of loops, times the change of magnetic flux over the change of time. In Lenz's law, which is discovered by Heinrich F. E. Lenz, he determines the direction of the induced current and stated that the induced current produces magnetic field which tend to oppose the change in magnetic flux that induces such currents.
Thank you, and see you in the next video.